Hello, everybody. Good morning. All right. Looks like we've got a good group of people logging on. We'll give it about 20, 30 seconds, and then we'll kick things off. All right, we're looking pretty good. I'm going to get things started here. Thanks, everybody, for jumping on the call today. We appreciate you signing up for the webinar and being here. Quick introduction of myself. My name is Ryan Norris. I'm with iAutomation. Been with them for about 13 years. In a second, I'll get a little bit into who we are real quick. Before we do kick things off, I just wanted to do a little bit of housekeeping. If you have any questions throughout the presentation, we've got the Q&A open. You can put questions in there or in the chat. Before we close the meeting today, our plan is to try to address any questions you might have, so feel free to throw those in there. Also, at the end of the presentation, there will be a QR code to a survey. We really appreciate it if you can take a couple minutes, just provide us with some feedback. This is a webinar series we like to keep ongoing. So if you have input on future topics you'd be interested in, or just want to tell us whether or not we did a good or bad job today, we want to hear from you. So we appreciate it if you take the time to do that survey at the end. So without further ado, real quick, I'm going to introduce iAutomation before handing things off to PILZ. For those who don't know, we're a high-tech distributor. We have a lot of engineering and value-add capabilities as well. We represent over 50 manufacturers, but we do have a more select catalog of products. PILZ is amongst them in terms of the manufacturers we represent that we call our MVPs. Along with the products that we provide to the marketplace, we also do a lot of controls engineering services, electrical, mechanical design capabilities, and we have fully functional panel shops in 3 locations for building electrical panels, extrusions, doing kitting, things like that. And at the end of the day, we try to have competency in all the products we support as a high-tech distributor, and we consider ourselves experts in supporting safe sensing and controls product implementations. And we partner with companies like PILZ for their capabilities and their products. So without further ado, I'm going to hand things over to JP and Joseph to tell us a little bit more about PILZ and jump into their presentation on risk assessments.
All right, thanks, Ryan. Yeah, so PILZ is a German-based company focused on automation technology. However, we do have a headquarters here in Canton, Michigan. I'm based out of Connecticut, and I cover our Northeast. And then we have other representatives up and down the East Coast and across the entire country as well. And those are our local territory managers. Joseph is our national channel manager, so he handles all of distribution. And we're going to kind of go over super high level risk assessments today. We were founded in 1948, originally as, like mercury glass relays. And then where we really became known was in 1987, where we invented the first emergency stop safety relay. Since then, we've continued to innovate, and our portfolio has expanded to safety controllers, PLCs, door interlocks, radar, laser scanners. But then we also have another portion of our business, which focuses on the topic that we're going to be talking about today, which would be training, certifications, and consulting, right? So risk assessment consultant, CE consulting, NR12, et cetera. But everything we do here at PILZ is specialized in safety. We don't really touch upon a lot of the standard aspects. I mean, we have products that work with our safety in conjunction because they're not, entirely mutually exclusive, but our core business is all in safety. So without further ado, we're going to kick it off. Those are some pictures of me and Joseph. I'm on the left, Joseph is on the right. I'm the one with the hair on the top half, and Joseph is the one with the hair on the bottom half of his face. All right, so OSHA and the General Duty Clause. So the OSHA Act of 1970 established the entity known as OSHA, the Occupational Safety and Health Administration. Within that, they are the ones who set and enforce safety standards within the United States, right? A key portion that I wanted to mention here is the General Duties Clause, right? So this clause is a blanket coverage that covers OSHA's bases in terms of if a standard exists for a specific hazard or a machine, which would be classified as recognized hazards, as you can see there in point 1, you don't have appropriate safety measures, you are liable even if it isn't specifically listed. That standard isn't specifically listed within OSHA standards like 1910 or 1926. So this is their catch-all, right? So that is something that I want you to be aware of, right? Just because it's not specifically listed in 1910 does not mean that you don't have to comply to it, right? If there is a standard that exists, you should have safety measures involved. So safety begins with a risk assessment, right? So you can't know whether or not your machine is safe or not unless you properly assess the risks. A risk assessment should cover all phases of its life, right? So from initial commissioning, in some cases, you can do DRAs, which is design risk assessment, all the way through to operation and then preventive maintenance, and then, at the end of its life cycle. It should cover all personnel who will interface with the machine during its lifespan. So that's going to be engineering, maintenance, the operators, all of those qualified people that will be working around or with the machine. And it should also consider correct use and reasonably foreseeable misuse, right? So not just if everything is going smoothly and everyone's using the machine in the complete proper way, as I'm sure anyone who's attending this call knows, that's not always the case, right? Sometimes it's with good intentions that accidents happen, right? And that could be foreseeable misuse, right? So the risk assessment methodology is going to be as follows on the screen here, right? So this is according to ISO 12100, but also in the US, there's the ANSI standards. So that would be like ANSI B11. But we're going to primarily focus on ISO 12100, which are the international standards. And it's the methodology that PILZ follows when we do our consulting. So once you decide to start a risk assessment, you're going to need to identify the limits of the machinery, identify the hazards, do a risk estimation, risk evaluation. Then you're going to look at those previous steps that you've defined, the limits of the machine. You've looked at what are my specific hazards, what's my HRN, which is hazard rating number, and we'll get into that later. And then you're going to evaluate it and say, okay, do I have an acceptable amount of risk? And you're going to do this on a task-by-task basis for the machine, so each individual task. If I have an acceptable risk, okay, I'm good. I'll move on to the next task. If I don't, I'm going to go into risk reduction and risk remediation, right? Remediation. And then if I do that, if I install, safety safeguards or safety devices, et cetera, right? Then I'm going to restart the process and I'm going to reevaluate the risks because I can introduce new risks. I may not have covered all of the risks that I was trying to with that measure. So these are all things that you're going to repeat until you are at an acceptable amount of risk for your company's risk tolerance. Okay. And that risk tolerance can vary depending on the company. But this is the general process of how you're going to do it. Okay. So clause 5 of ISO 12100 is going to cover all the aspects of a risk assessment, right? So we're going to be looking in 5.2 machinery description and specification, right? So that could be user specifications, machinery specifications for the different phases of its life, drawings, energy sources. So we're not even just talking about electrical. We could be talking about hydraulic, pneumatic, etc. Documentation as well, operating manuals. And then relevant regulation standards and other applicable documents, right? So if there's a specific standard relevant to your type of machinery, let's say a press brake or something, right? There's certain type C standards and things that you should be referencing when you're doing these risk assessments. Previous experience of use of machine types, right? So that kind of comes into the qualitative portion of it, excuse me. And then ergonomic principles, right? So if you've ever been around an EHS guy, one of the biggest, I'll say, risks for operators is repetitive motions, right? So repetitive motions create ergonomic issues, things like that, right? So we're going to be looking at both qualitative and quantitative information, where qualitative is going to be more of that experience, right? Have there been accidents in the past on this machine? Where are there known risk points or hazards that we've seen? And then for quantitative, that's more data based, right? You could be looking at specific specifications. Okay. And then in bold on the bottom there, we have the absence of accident history, or a small number of accidents or low severity should not be taken as an automatic presumption of low risk. So just because something has never happened before does not mean that there is a low risk. Very frequently in machines, I'll see, well, we've been operating it for 30 years like that. No one's ever gotten hurt before today. That doesn't mean that the risk is low. That just means that you've been lucky. Or maybe you've had an operator that's been working for the entire 30-year lifespan that this machine's been out there, and then you hire someone new, and now these risks become apparent. So when you're looking at the limits of machinery, you're going to be looking at the use limits, so operating modes, intervention requirements. So like if there's a jam in the machine and someone has to go in there and clear that jam, right? That's a potential for an injury. Intended use, foreseeable use, reasonably foreseeable misuse or malfunction. Anticipated levels of training. So based on how experienced an operator has to be in order to work on that machine, this kind of comes in later on when you're looking at like performance levels and stuff. But for specific types of machinery, you can take a PLD and lower it to a PLC if there is a training requirement, right? That they have to be a specific level of trained. And those are generally, well-established practices that are referenced in the standards. But that's kind of, once again, that comes back to the risk tolerance of your company, whether or not you just want to declare it a PLD, or you can say, okay, well, we only need PLC because this standard specifically says that I can drop it with experienced operators, right? And then exposure of other persons to the hazards where it can be reasonably foreseen, right? So it's not always just the operator that's working in front of the machine. If I have an ejection from a machine, right, that could affect not just me, but also the people behind me walking by. Space limits, so range of motion, space requirements for people to interact with the machine, the human interaction, and then the machine power supply interface. Okay. For determination of limits, right, we're going to be looking at the life limit of the machine and components used, right? So if there's PM cycles and we need to change a tool every XYZ, right? And then the recommended service intervals in there. And then other limits, right? So we're going to be looking at environmental, right? What's the environment of the machine or where people are working, housekeeping and cleaning requirements, right? I need to change the coolant X many times. I need to change the conveyor after so many months. And the properties of the actual materials that are being processed, because those can create byproducts, right? And then for task identification, we're going to be looking at all the tasks associated with every phase of the machine, right? So that could be setting, teaching, training, programming, actual operation, cleaning, maintenance. And all of these tasks, when you're doing these risk estimations and hazard identification, you're looking at it without the safeguards, right? So unless it is a fixed portion of the machine that is fastened and not intended to be removable or accessible, you're going to look at it as a raw risk, right? I'm not going to take into consideration, I'm looking at a machine, it already has light curtains, right? In my initial risk assessment, I'm going to look as if it doesn't have any light curtains or it doesn't have an interlock, right? I'm looking at the hazard itself. And then when I get to the risk reduction, I could say, well, now I put the light curtains on, and when I reassess it, I dropped it down to my residual risk is now only, in the green. It's a 50 or 100, et cetera, right? But that initial risk I'm going to be look at as if there's no safeguards on it, right? Just the machine itself and the risk itself. And then Annex B of 12100 outlines origins of the hazards and potential consequences. And then for some mechanical examples of hazard identification, we could be looking at crushing, you're at a press, shearing, cutting, and severing, so permanent loss of limb or a cut on your arm, entanglement, drawing in, so getting pulled into a machine, impact, getting struck by something, stabbing or puncture, friction, abrasion, high pressure fluid injection, ejection of material, and pressure and vacuum. Okay, in this picture over here, you could see someone getting drawn in or entangled. For non-mechanical examples, we're going to be looking at things like electrical, right? So inadequate design of control systems, noise. So during CE assessments, we have people who walk around with meters for potential hearing loss, so they measure the actual decibels. Vibration, thermal, so whether that be burning or freezing, etc. Fire and explosion. Material and substance hazards, so inhalation of mist or byproducts of a process, right? Chemical agents, biological radiation. Are you going to turn into the Hulk around this machine? Hazards associated with the environment. So is it a dusty environment? Is there a lot of fog? Is there a lot of moisture? Is there a lot of pollution, etc., right? And then also in hazard identification, something relatively new with the CRA or the Cyber Resiliency Act and the transition from machinery directive to machinery regulation. This is more based in the EU, but a lot of things matriculate down from Europe to the United States, is the idea of IT versus OT separation. So if we're looking at this image here in the gray, this is going to be our overall IT structure. So that's what everyone who's logged on right now, you're on your company's IT system, right? You're connected to the internet, things are all interconnected, you're locating servers, etc., right? And then on your actual machine, this is going to be your OT, your operational technology. So with the CRA and the machinery regulation, there has to be an isolation of your OT from your IT, right? Basically to protect the machine from unauthorized access so that not anyone can just log in and start making changes, right? So what we have here in the middle is basically a firewall that will open up a VPN tunnel to allow you to access the PLCs here and the controllers to make changes or view certain things, right? And you have to have certain credentials, etc. And this specific unit actually does check some of PILZ specific software as well. But that's creating this barrier between your operational technology and your greater IT system if it is interconnected, right? So let's say you have a SCADA system that you're looking at, or you are doing remote support of a machine and it's connected to the general IT structure, right? There has to be an isolation there, and that's the security portion. Okay. A quick example before I turn it over to Joseph would be, in recent history, a nuclear power plant was actually hacked and they had access to all of that machinery, right? So they're trying to create that isolation, and that's what the CRA and the machinery regulation kind of focus on in addition to AI and things like that. And then Joseph's going to continue on with the rest of the PowerPoint here. So Joseph, if you want to take control.
Perfect. Thank you, JP. So as JP talked about, once we finish the hazard identification part of this, the next thing we're going to go to is risk estimation and risk evaluation. So whenever we're looking at this, the ANSI standards and the ISO standards 12100 and B11, they don't go in real in depth on how to do a risk estimation or risk evaluation. They give some general guidelines. And so people kind of have to figure out the best way to do this. So the two things you really want to look at is probability and severity, right? So probability, what is the chances something bad happens? And then severity, how bad is the bad thing that happens, right? So if you have high probability, high severity of something bad happening, that's a no-go zone. We don't want to do that. We don't want to be, in this area up here, where, hey, every time we do this, there's an 80% chance someone loses a finger, right? We're not going to allow that, right? What we want is we want to stay down in this area where we're going to be low risk, low severity. Now, what can happen is there some times you're in this middle area in any of your applications, right? This could be, say, work on energized gear, or you're working on a high pressure system where you have to actually need the pressure engaged, right? So but if you're gonna be in that middle zone there, we're gonna say, hey, has to be a highly trained person. It has to be someone that knows what they're doing. We're going to take extra precautions. We're going to put them in the arc flash suit. We're going to do some stuff to make sure that they're okay while working in here. And that shouldn't be normal operations. So then when we get into risk estimation, we're going to look at a couple of things. So there's a number of different ways to do risk estimation. You can see a lot of people use the RIA formula, which is basically like a little flow chart, which is similar to like performance level. The only issue is that it's not very granular. So it'll say, hey, you have extreme risk, high risk, medium risk, low risk, negligible risk, or low or extreme low risk. So you can have a lot of different applications that all land in the same high risk, and you're like, what is the most high risk of my high risk applications or high risk hazards? So we at PILZ, we like the hazard rating number. So the hazard rating number was a system that was designed by a guy named Chris Steele in the 90s. He published it in Health and Safety magazine, which if you're looking for some good reading material to fall asleep to, please get a subscription to Health and Safety magazine. But this is a way that we can look at likelihood of occurrence, the frequency of exposure, degree of possible harm, and the number of persons at risk. And then we do a real complicated math program or a math equation to multiply some values together. And then we use golf scoring this. So high number bad, low number good. If you have a high number from these values, then we have a high risk situation. If you have a low number, we have a low risk. What's important to realize, though, is that you'll never have zero. You're going to be having people interacting with machines. So you're going to have some residual risk no matter what you do. So what we shoot for is as low as reasonably practical, or ALARP. Now, the RIA standard, the hazard rating number, these are not the only ways to do risk estimations. Those are probably the two most popular. I come from the nuclear Navy. We had our own, naval way of, naval and nuclear way of assigning risk when we were doing applications. Aviation has this weird bow tie diagram. Process safety has their own way of doing safety. So whenever we're talking about risk estimation, so there's a lot of different ways to do this same thing, but we're just for time's sake, we're going to just talk about the hazard rating number here. So these are some of the values that Mr. Steele came up with, and you can see the degree of possible harm, goes all the way from scratch, bruise, something minor, a 0.1, all the way to a fatality of a 15. Frequency of exposure, infrequent to constantly, and you can see some of the values associated with all of these. We're going to come back to this here shortly, but these are some good numbers. What we also really like about the hazard rating number is you can adjust these to match your risk tolerance. So that we have some people that we do risk assessments for or safety audits for, and they're like, hey, for a fatality, we actually want that to be 25. We really want to make sure that this is a big number and we know something bad can happen here. So those can be adjusted for you guys as well. So once you finish the risk estimation of how hazardous is my hazard, the next thing is you're going to do a risk evaluation. This really happens in the same time as the risk estimation, because the estimation is how dangerous is it, and then the evaluation is that acceptable, right? And so some people can just say, hey, here's some different values, and again, based off your risk tolerance, you can change this. You might say, no, we got to shoot for anything less than 10, or hey, we know we can't get less than 150 on this application because we got to work on energized gear, or we got to do maintenance on this robot, and then we have to have someone in there moving it and get really close whenever we're dialing in some of those finer points. So we're going to be next to the robot. There's going to be some hazard there. But we're going to take whatever precautions we can to lower that risk, to ALARP, as low as reasonably practicable. So once you finish the risk estimation, the actual estimation of how hazardous it is, Then the evaluation point is this acceptable or not? Or do we need to do more work? So we got a little risk estimation lab to kind of walk through this on one hazard for one task. So like JP said, we do task hazard analysis. So for each task that you have, you're going to probably have multiple hazards. So here we have a CNC machine, the finger remover 3000. And like JP said, when we're doing the initial analysis, we act like there's no safety on it at all. There's no guarding, there's no light curtains, there's nothing. We're just looking at how dangerous is this machine if it was just a wild out in the field by itself, right? So we're going to look at how hazardous it is to begin with, and then what can we do to reduce that risk, right? So when we're looking at these, we're going to look at what are the different types of degree of possible harms for this different application. So for a CNC machine, we're looking at this and we'll say, okay, for the degree of possible harm, I would say that, if I've got a task where I'm loading and unloading a CNC machine, I'm going to be reaching in there, placing the blank in the chuck, taking the blank out, that I'm going to actually, I can actually lose a hand from there. I can lose a limb or loss of one limb, right? I get my hand stuck in the chuck, right? So I would say, all right, I would evaluate that as loss of one limb, right? And then, frequency of exposure, I'm changing this out, every 10 minutes or so, or however long it takes for the CNC machine to run. So I'm going to be there constantly, basically all the time. Someone's just opening the door, put the new one in, take the old one out, right? And then when it comes to likelihood of occurrence, that's when it really becomes a judgment call, right? You have to look at you have to do some, kind of qualitative analysis on this and say, hey, based off of experience, based off this machine, what it's doing, my initial assessment, if there was no safety on this, there would be no doubt in my mind over the lifetime of the machine, someone's going to get hurt this way. Someone's going to lose a finger, right? And then the final thing you look at is, hey, how many people are involved in this, right? If it's just one person loading and unloading a machine, pretty easy quantitative analysis there, 1 to 2 people. So we can take these selections from each of these, multiply the values associated with them together, and you see the first one lands at 450, very high risk for our application, right? And so now we have a starting point. We know how hazardous this hazard associated with this task is. And so each task might have multiple hazards associated. You might say, hey, there's a hazard of tripping and falling. There's a hazard of ejection, metal shavings ejecting, if there was no guarding or something like that on there. It might be high pressure fluid injection, hazard of, what do we do with cutting fluid, that kind of stuff. So we want to look at it. You'll have for each task, you'll have multiple hazards associated with it. And so what we'll do is we'll take a look at those hazards and then we'll do risk reduction. And so we'll go through this little flow chart here. We start with our risk evaluation, with our risk analysis. We'll start and say, hey, has it been reduced? No, we're just starting, right? So let's say, can the hazard be removed by design, right? Can we change something about how this CNC machine works, right, to reduce the risk? Well, not really. It's a CNC machine. It's got to spin. It's got to cut metal, right? So we can't really change how it works inherently because it has to actually make a part. So we'll say, no, we can't really change the design of how this, cuts metal. So the next thing is, can we reduce risk by using guards or protective devices? Absolutely. We can put a safety locking switch on there. We can put a good safety relay, safety controller on there. We can do some stuff for the maintenance, make sure we have a good lockout tagout procedure, all that kind of good stuff, and make sure that we've done some risk reduction there. So yeah, we can do that. And then we'll say, is it an acceptable level? Maybe yes, maybe no. If it's no, then we'll go down here. Can the limits be specified again? So JP talked about the limits earlier. We're saying how many people are working around it? How often are they working around it, right? So can I say, instead of being there every 10 minutes, maybe we put a robot in front of it. Maybe we put something there to load it. And now I'm loading a robot, once a day instead of having to be around the CNC machine all the time, or maybe some kind of something else, right? So we follow through these steps, and then eventually we'll get to where we say yes over here when we believe we have an acceptable level of safety. And then we'll jump up here, and then there's this little row bump here that says, hey, in producing your solution, did you generate any other hazards? And it's like, well, if I added a robot, yeah, I did. So I got to go and then do risk analysis on that robot there, right? And make sure I'm taking care of all the hazards associated with that. And so we do this is what I call the risk reduction carousel. We'll go round and round on this until eventually we'll get to the point where we can say for each application, this machine is safe or as safe as it can be, down to ALARP. Now, one of the reasons why I like the hazard rating number is it's going to be very granular. Each hazard is going to have a different hazard number associated to it. And so this looks like a lot of work. You know, you got to go through this on each individual hazard. But with the hazard rating number, we would just start with the biggest number because we know that's our highest severity, highest probability. Let's start there, right? And then we'll work our way down. And in solving some of those higher numbers, those higher hazard numbers, we solve a lot of the lower stuff. You know, if I put a lock in a door and a lock and a lockout, tag out, and stuff like that for the spinning sharp bits in a CNC machine, well, then I've also solved my ejection problem. I've also solved cutting fluid, spraying out of the machine. I've solved 3 or 4 other things. So that's why I'm a big fan of the hazard rating number. Whereas if you look at like the RIA standard, you kind of just have like, here's all of these that are in kind of high risk, and you don't really know where to start. Where the hazard rating number is like big number, start there, move on. All right. So we're going to look at, how can we reduce the risk? We got different things. We got safety relays, safety controllers. If you got a big system, you can get the safety PLC. You got different locking switches, magnetic, mechanical, light curtain scanners, radar systems, safety radar systems for dirty, nasty environments. And then, just your say e-stops and switches. There's lots of different ways, as long as you do it in accordance with ISO 13849, to wire this up and make sure that you have the correct system for the hazard associated. So we look at this and we say, all right, we put a safety lock on here to make sure the door's shut, it's locked, it has good OSSD outputs. Those outputs are going to a safety controller, and that controller is saying, I'm monitoring all those with either test pulses, or it's looking at its own looking at OSSD outputs of the switch. We got our lockout tagout procedure. We got our robot in here that's loading and unloading it. So I'm not around the CNC machine all the time. I'm just loading a magazine to the cobot. And now I can say, hey, this isn't the finger remover 3000 anymore. This is a, as low as reasonably practicable, safe CNC machine. And the other value of using the hazard rating number is now I can say this is how much we reduce the risk, right? So we look at the degree of possible harm and we go and re-ask these questions once we've done our risk reduction, right? So degree of possible harm, we didn't change how this machine works. It's still got spinny sharp bits in there. So it could, if something bad happened, you could lose a limb still. So that hasn't changed. That value hasn't changed. Now, if you change, now I've seen like where robot cells, they actually change the layout of the robot cell. And then I can't get into, in a certain task, I can't get my whole body in there. And so you might go from fatality to break a minor bone. So you can reduce it that way with the design change, right? But where we really reduce our risk is we go from we're constantly around it this time to now we're just around it daily. So we won't go from a 5 to a 2.5. And then we look at the likelihood of occurrence, right? So we go from certain, no doubt, someone's going to get hurt on this, to where if I have a good safety subsystem, I've trained my operators to where they're competent and capable, right? And I do my maintenance on it like I'm supposed to. It would be highly unlikely, although conceivable, that maybe something could happen here, right? And then the number of persons hasn't changed. It's still one person, but instead of loading the CNC machine by hand, he's loading a cobot, right? And so now we can show numerically that we went from 450 down to 7.5. And so we get to show our EHS guys, hey, we have reduced the risk here. We have shown that we have actually reduced risk and we have made this safer. All right, well, that leads to a great question. So who should be doing a risk assessment, right? And so at PILZ, we say you need three things. You need experience, training, and qualifications, right? So qualifications, you're a certified expert in functional safety, or you've been through a TUV functional safety class. You understand the basics of machinery safety, right? Training, you've been through, you have training on that specific machine, or you have training on, we do a risk assessment workshop where you can actually come in and it's a full day that we just go in depth on risk assessments and how to do risk assessments. You can take that class and we teach you how to do a risk assessment, with certain methodologies to where you do the same thing every time. And then experience, right? I don't want to see, the 22-year-old fresh out of college, engineer, with a clipboard going up to a machine when this is the second time he's seen a FANUC robot in his entire life, right? Like I want someone that's has some experience, been around the plant, that knows the machines, that knows, that knows machinery safety and the standards that are associated with, B11, ISO 13849, whatever standards you have in your own area, right? So this is what we say: you need experience, training, and qualifications to have the correct skill, to have the competency to do a risk assessment. And what this usually turns into is a risk assessment turns into a team event, right? The operators are around the machine more than anyone. They know how that machine works probably better than anyone, except maybe maintenance, right? Engineering designed it. They're making changes to it. EHS, they come from a health and safety background, right? They're looking at this and saying, hey, what are some of the ergonomic principles and stuff we wanted to avoid, right? And so what it becomes is a team event. You get a couple of people in there. When PILZ goes and does a risk assessment, our consultant is actually asking a lot of questions. How do you do this? Walk me through this. Show me this process. Walk through, how you would load this or unload this. What are you getting involved here? Where do you reach? Where do you, can you crawl under this? There's lots of questions with pretty much everyone involved, just to make sure that we have a complete understanding of the machine that we're looking at here. And then the final thing is, once you do the assessment, the machinery safety evaluation, risk assessment, whatever you're doing, and you've done the remediation, the final thing you're going to do is a validation. So you're going to look at the machine, you're going to make sure that your assessment, all the things that were called out in your assessment were actually, the risk was reduced as low as reasonably practicable. You've actually you've looked at each hazard and you've said, I have addressed this one, I have addressed this one, I have addressed this one. Here's how we did that, right? And then we're going to check for proper implementation of the safety design to make sure it's installed correctly. It's, hey, I decided this needs to be performance level D in accordance with the standard. Or if you're on the IEC standard, this needs to be SEAL 2, SEAL 3, whatever safety integrity level it needs to be. Did I do my safety circuit correctly, right, in accordance with that standard? So a couple of different things we're looking at. We're going to review the machine risk. We're going to do a mechanical guarding example. So we're going to actually go and measure things, make sure my guard's the right height, the right distance away. I can't reach over or reach through or reach around something. Safety related control circuit examination. So I'm going to look at my program. I'm going to look at my relays, make sure they're wired up correctly. I'm going to go and test every switch. I'm going to hit every e-stop, make sure that it sends the signal correctly, right? And you don't got to run your giant KUKA robot into a hard stop, but turn it on. Make sure that, hey, it gets the signal to the brakes to it gets this actual signal to the robot or to the safety valves or whatever they're going to say, hey, when this happens, when I break this light curtain, I'm testing my light curtains, not with your fingers, with a stick, right? Don't stick your hands into light curtains on purpose, but with a stick, and I test the light curtains. My machine operates as expected. So we're going to do a functional safety test and look at the software, make sure everything is set up correctly. And once you do all of these steps, when you go from, machine settings, the limits of the machine, who all does it affect, and we have a good idea there, to the, hazard identification portion. That's the one everyone knows. You run around with a clipboard, you're writing things down, taking pictures, right? To estimation, evaluation, remediation, And then you finish up with validation, saying, I have now know that this machine is ALARP. All the hazards are as low as reasonably practicable to still be able to make the part, right? Then we can say we've completed what we call the machinery safety life cycle. And then the only next step is, reschedule it in 3 or 4 years. God, Lord knows, you get a brand new machine in 6 months later, it looks a little bit different than the way you installed it. So then you start over, 3 to 5 years down the road to reassess your machines. So that's a very high level general overview of machinery safety in about 45 minutes. We do a full 1-day class just on risk assessments. PILZ also does a 1-day intro to machinery safety workshop where we cover standards, risk assessments, safety circuit design, guarding, kind of a high level that goes over everything. That's a whole day class. We're planning on hosting some of these with iAutomation. So get with your iAutomation guys so we can get those scheduled. And with that, Ryan, I'll turn it over back to you.
Thanks, Joseph. Thanks, JP. Appreciate you guys. Great stuff. Yeah, to Joseph's last point there, please do, take a moment to fill in our survey. 1, to give us some feedback. 2, there's the option there to reach out if you're interested in engaging more on this topic or finding out more about either PILZ services or anything else we can provide there. It's a good way to provide us that feedback. So really appreciate if you could do that. Before we do sign off, we do have a question for you guys from the chat, just one here. So coming from Edward, specifically interested in design and build of automation equipment. He's asking, at what phase of a project will this assessment be performed? So when does it make sense, I guess, to perform a risk assessment?
Yeah, so I can answer this. If this is, there's a couple of different ways to do that. If you're doing brand new build like this, we're building machine in CAD and it's brand new. What I actually recommend is what we call a DRA, a design risk assessment. So you take your CAD, your drawings, your schematics, and everything. We evaluate all those, to say, hey, based off of where your fencing is, based off of estimates on time stoppage and stuff like that. We can do it in the design side, right? Because it's a whole lot easier to move a fence, a whole lot easier and cheaper to move a fence in SolidWorks than in real life, right? So that's a great question if it's brand new. If you don't do that, we've had things where no one really thought about safety until it landed on the floor, and then they go to the EHS guy and say, hey, sign off on this machine, and he's like, no, I'm not doing that. Then it can, we've had things where, hey, you got to move guarding, you got to add the scanners. I had an application where someone was, they had a UR cobot ironing a automotive seat, and they didn't have any guarding around it. And they said, we shouldn't have to have guarding. It's a cobot. And I was like, it's an iron. You got 200-degree steam coming out of it. Like, I don't care if it's a cobot. I have opinions on cobots, but
we've got another question here. I do want to. I think just to summarize what you had said, better to do it during the design phase of new equipment. Obviously, it can be implemented during any time in the process and is more required once you have equipment fully built. But I've heard this adage before where it's easiest to try to design around safety challenges if possible, right? With the machine limits and everything you guys discussed earlier. Second question here from Christopher. Is it more beneficial to have a third-party perform a risk assessment, or should it be kept internal since those people are working with a risk daily?
That's a... Go ahead, JP.
Yeah, so it kind of depends, right? So it really depends on the amount of knowledge within your organization, right? So if you are able to build up enough of that knowledge, right? So Joseph had a slide a couple slides back that says who should be performing these risk assessments, right? So if you have enough inbuilt knowledge and people that are trained, then there's nothing wrong with doing it yourself as long as you guys are comfortable doing that, right? And standing behind that work. We have a lot of clients who will go to our trainings, things like CMSE, CEFS, and get certified. These are TUV certification trainings that we offer, where you will get certified in risk assessment, certified in all these standards, and then you can build that knowledge. If you are not proficient enough in doing that, you're not doing it frequently, I'd say it probably would be beneficial to have someone else do it to ensure that the work is covering everything that could possibly happen, right? Because with risk assessment, specifically in our PILZ consulting projects, right, we will list out all of the standards for every single hazard that we address, right? So we'll say, this is a pinch point, XYZ, here's the injury, here's the specific standard that references this hazard, right? So there are a lot of standards, and that's another kind of factor, is there are a lot of standards, and standards are expensive. So without the knowledge of all the standards or what standards to reference, that can be difficult. But if you're doing it on a somewhat regular basis and you have the inbuilt knowledge and confidence to do it yourself, then absolutely you could do it yourself.
Great.
Just to
We
just to
we
add
do
on
have
to
we're running we're out of
Okay.
time, but we do have a couple more questions. Anybody who's interested in signing off, feel free. If you've asked some questions, we're going to hang on for a few minutes and see if we can get these guys to answer those. So feel free to stay around. I just wanted to let everybody know that obviously you can log off anytime you'd like. We don't want to go over time except to try to answer the questions that we still have from the audience here. So trying to move along here real quick just to try to get to everyone. Next question here from the chat from Steve. How harmonized are ANSI V11 and ISO 12100? Reasons to use one versus the other if your organization hasn't already specified.
Yeah, so the ANSI and ISO standards are very, very harmonized. There are some little differences, but ANSI, it's hilarious. ANSI B11.26, literally the name of it is how to use ISO 13849, right? Like, it's more fancier than that. So and you want your national standards and your international standards to be harmonized, because if you leave, if you say you go from America and you go to Canada, you hop across, you go to work in another company over there, you want those standards to be pretty similar, right? There's going to be certain things that American law requires, in OSHA. There's going to be certain things that Canadian law requires, but for the most part, it's pretty harmonized. Now, why would you choose one over the other? Most international companies, they just go with ISO standards because it's the international standard, or the IEC standard. If you just have like one plant in America, you might just stick with ANSI and OSHA just because that's your only one. But if you open up B11 and then you go get ISO 12100, they basically say the same things, different language and stuff. But as far as the methodology and that flow chart, you're basically going to be doing the same thing in both of them.
Sounds and good. Just to add a quick note on that, one of the differences as well is that ISO standards, because they're internationally and EU based, right, for the most part, they cover a lot of things about manufacturers as well, manufacturers of equipment, where ANSI is more on the end customer that has these machines installed, because in the US the responsibility sits on the end user. However, that doesn't completely remove any responsibility from the supplier of the machinery, as we live in a very litigious country. So if they can prove that there was negligence of design and negligence of safety aspects, you could get sued anyways. But that's just another small difference. But to Joseph's point, they're extremely harmonized, and within the ANSI standards, there are actually specific references on how to draw parallels and use one for the other. Yeah.
Great. Hopefully that answers the overall question in terms of, sounds like the context is, yes, they're harmonized. The second part of that is a little bit more dependent on what your current situation is. Globally
Right.
Speaking, how global are you? Are you running a facility where you're producing stuff, or are you building machines that you're shipping to customers, right? And if you have more questions on that, I'm sure PILZ would be happy to provide more info. Last question here, at least that I've got right now. Where do you draw the line on expectation of safety design, such as designing a guard that is fine if treated logically, but can be defeated if the person is determined to go around it? They go under, over, remove, etc. How do you know
Yeah.
when good is good enough?
You know, you make something foolproof and they make a better fool. Like that's there are specific stuff in guarding, right? I can't control someone climbing over a fence. That's willfully violating, the guards. But I've seen stuff where the guard's 3 feet off the ground and you can easily duck under it. So it really depends on the tolerance of the EHS manager, the tolerance of wherever this sits. OSHA holds the end user responsible for the most part, right? Like they're going to look at that and say, hey, here's the OSHA guidance on guarding. This has to be less than I think it's like 150 millimeters from the bottom of the ground, so you can't crawl under it, right? Don't quote me on that. There's a lot of specs and numbers I don't know off the top of my head, but yeah, we can't bubble wrap these machines, and that's why we look for ALARP, right? We look at the guarding standards in B11 and ISO, and we say, hey, we're following this to the best of our abilities, right? Every EHS guy says, I don't want anyone to ever be able to get hurt. And every operations manager says, well, we can't make our part now because we can't turn this machine on, right? So how do you do that? Great question. That's basically our whole job is how do we make a part while making sure someone doesn't lose a finger? And then drawing the line becomes a company by company standard.
Yeah, and just last point on that as well is as long as you are designing to a standard that you can point to, right? You can say, we designed like Joseph said, right, in 13849 dash whatever, right? It specifically says that it has to be XYZ off the floor, and I have to have a minimum height of this because of reach over requirements, right? But if someone's going to climb over the cage, that's that's outside of this, right? And that can also get covered in your documentation, right? So if you're looking at like exporting machinery outside, right? But if you're building the machine and you set in your documentation limits, right? Once you've established that we followed these certain standards, right, and this machine is built to spec on these standards, however, there are these circumstances, that you should not do, and you specifically list those in your operating manuals, your technical documents, add limitations of the machinery, right? As long as the machinery is built to a standard and to a level, then you can consider that sufficient. I think the other side of it too is it's not included on here because we were short on time, but there's a slide that we use that shows the cost of safety and the reduction in the amount of hazard, right? So to a certain point, you're going to you want to get where these curves match, right? Where you're going to get the biggest reduction in safety, and you're going to have for the minimum amount of cost, right? You want to be a little to the right. You want to make sure that you can say that you've sufficiently, for sure, reduced the amount of cost. So you want to be a little to the right of where those intersect, right? But at a certain point, you reach a plateau of limiting returns, right? Where you're going to say, okay, I can add another safety device here, but it's going to get me an additional 1% of safety for an extra $600, right? That's also kind of a limit there where you're like, well, that doesn't really make much sense. I've already reduced it by 80%. To change it to 81% add $600 in cost. Where's my return there, right? So I know we're over time, but these were great questions.
Yeah, really great questions. Thanks everybody for putting those in the chat, and thanks again everybody who did join. I'll pitch it one last time to get a chance to take our survey. We really appreciate the feedback. We're going to be doing additional webinars throughout the year. So if you have input on other topics of interest that you might have, feel free to throw it in there, and we'll be sure to invite you on the next one. So thanks again, everybody. We appreciate you turning up and providing your questions and feedback. Hope to see you on the next one. Bye, everybody.
All right, guys. Thank you.